Well, hello again. This is part two of our inflation notes, and what we're going to do with this set of notes is think about applications of the average price level. So, textbook reading, it's section 12.3. In terms of thinking about where we were in the first set of notes, this was part one. This is what we're going to be thinking about here with these notes, and then this will be the last bit of stuff that gets posted for this week. The only thing that I want to draw your attention to is just that to be consistent with the order of the way things were presented in the book, I moved the interest rate determination stuff up here. We'll actually talk about interest rates again in that third set of notes, but more in an applied way rather than as we're doing now, which is to define them. So we, in the last set of notes, talked about different measures of an average price level. So by price indices here, what I mean is an average price level. And these are, we talked about the consumer price index, the deflator, the producer price index, and so forth. So those are all measures of a P. And so obviously, one thing that we can do once we have two values of an average price level is to calculate an inflation rate. So done and done. We did that in the last set of notes. What I want to think about at this point are two specific examples of how price indices are used. One instance of this is to index a nominal variable. And this is done in order to ensure that there's a constant level of purchasing power. So the real here is really redundant. So purchasing power does refer to the real quantity of goods and services, or the inflation adjusted quantity of goods and services that a person could purchase, for instance. So we see in the macroeconomy wages indexed, certain labor contracts, Social Security benefits, tax brackets. There's discussion of indexing, and many states do. We'll go through an example of this, indexing the minimum wage in the state to the level of inflation and so forth. And then the second thing that we do commonly with an average price level is to use it to compare nominal values of variables that occur in different time periods, where either we know or we expect that there has been a change in the average price level, or that there has been inflation over the time period. And so again, this is getting at questions like, are wages higher now than they were 20 years ago? Or, is my income keeping up with the pace of inflation? So we'll see some examples of this later on. What I would like to do first is to consider an example of how a nominal variable is indexed. And so often for labor contracts, the consumer price index is used to construct a cost of living adjustment. So again, this is predicated on the idea that we think about the CPI as measuring cost of living, and we discussed and thought about some of the qualifications to that earlier. And you could follow these two links if you chose to get further information about this. What I have at this point is working up to an example of thinking as an approximation how Missouri indexes its minimum wage. So what I have is the consumer price index in 2017 and the consumer price index in 2016. Remember that conventionally we take whatever the value is, multiply by 100, so we get some more significant digits. What I would like you to do is to calculate the inflation rate. And so this will be our first participation question. So you would have calculated the rate of inflation by looking at the growth rate of the consumer price index. So the inflation rate, again, is just the percentage change in the average price level. And in this case, our measure of the average price level is the consumer price index. So when we're constructing a growth rate, we would take, for instance, the CPI in 2017, subtract from that the CPI in 2016, divide that by the CPI in 2016, and then again we multiply by 100 to get it expressed in a percentage. And so if you did this, what you should have found is that the rate of inflation is, well, okay. So what you would have found is that the rate of inflation was 2.20%, or if you had just done this first part of the calculation, so 247.411 minus 242.081, you divide that by 242.081, that's going to give us 0.022. And so again, multiplying by 100 expresses this then as a percentage. So we would say that over, according to the consumer price indices for 2017 and 2016, the rate of inflation over that year from 2016 to 2017 was 2.2%. To index a wage rate, what we're going to do is to put, not in percentage terms, but in just the level, the value of the inflation rate. So inflation rate that we're putting in is not the percentage, not, or maybe, I'm sorry, not in percentage terms. So specifically, in Missouri, for instance, in 2017, the minimum wage was about $7.70 per hour. The inflation rate, according to our consumer price index measure here, would be 0.022. So we would multiply $7.70 times 1.022, and that would give us a nominal wage rate of $7.87 per hour. And so this would be what we mean by indexing, in this case, a wage rate to the inflation rate. In other words, as you can do, so you can check based on what we're about to do next, is the real value of the wage in 2016 and 2017 the same? And you should find that the answer is yes. And so this would be an example in which moving the wage from $7.70 per hour to $7.87 per hour maintains purchasing power. So in other words, on average, in the macroeconomy, prices rose by 2.2% over this year. That would mean that with if you wanted to buy $100 worth of goods and services in 2016, you would need $102.20 in order to buy that same set of goods and services in 2017. That's what we mean by inflation. And so what that means then in this particular case, if it is the case that the nominal wage rises from $7.70 per hour to $7.87 per hour, that 2.2% increase ensures that what you could buy with $7.70 is the same as what you can buy in 2017 with this $7.87. That's what we mean by maintaining purchasing power. It means that you have the ability to purchase the same quantity of real goods and services in the macroeconomy. The second thing that I want to turn to in terms of ways in which we commonly use price indices is to compare nominal values across time when we know or we suspect that prices haven't been constant. And so this allows us to avoid a phenomenon that's known as money illusion. And we all often fall into this trap. So, you know, I could say, I don't know, my dad used to always say, oh, you know, when I bought our house back in whatever it was, 1964 or something, it cost $27,000, and now a house costs $500,000. Well, that would be an example of suffering from money illusion because over those intervening years as well, the price of all goods and services rose. So when we suffer from money illusion, we have the mistaken tendency to focus on the nominal dollar numbers that we see floating around instead of inflation adjusted amounts. And so we've already seen this to some degree. We noted when we were talking about real gross domestic product that it would be misleading to focus on growth in nominal gross domestic product as a barometer of whether our standard of living has had improved. Rather, what we should do is focus on growth in real gross domestic product because that would be taking into account the effect of price changes. And we also saw this in our approximation that we'll come back and use a little bit later as well, where again this right here is the inflation rate. So it's this idea that looking at nominal values conflates or blends together changes in the underlying real value of a variable and its and inflation. So these two links, these are just for fun. So this one takes you to an article from a couple years back in the Atlantic Monthly where they were talking about the creation of a meme called Old Economy Steve, where Old Economy Steve spends a lot of time suffering from money illusion. And this particular hyperlink takes you to some examples of it, but you could just Google Old Economy Steve meme and you would see exactly what I am talking about. So that's just for giggles down the road. So, how do we go about deflating? Or, in other words, what we're doing when we're deflating is we're calculating real values. And we've already seen this. We've seen this when we talked about real and nominal gross domestic product, right? So we saw that when we had the deflator, for instance, we said that that was nominal GDP divided by real GDP. And again, we could multiply by 100 here to get more significant digits. And so therefore, if we wanted to think about this notion of a real value, we can just flip this equation around. So in general, when we were talking about price indices, one of the either the last slide or one of the last slides in the previous set of notes, the point of that was me trying to convince you that whether we're talking about the CPI, the deflator, the producer price index, it's always this comparison of the nominal value of a basket of goods, whether it's everything that the economy produces or just a subset of that in the CPI or the PPI, relative to the real value of that same basket of goods. In that particular case, just this was what we were talking about as a price index. Just more generally, we can flip this around and say the real value of a basket is going to be the nominal value of the basket divided by the average price level, or if we have the average price level grossed up by this 100, then we're going to divide by 100. So the real value of any nominal variable is the value of the nominal variable, whatever it is, GDP, wages, house prices, whatever, divided by the average price level. Or again, depending on how that average price level is expressed, sorry about that. Oh my goodness. We would have the average price level divided by 100. So conventionally, in anything that I would give you, it'll be like the example that we're going to see next, where you would be doing this division of the average price level by 100. So again, the point of this is that it's useful for comparing nominal values across time when we know or we suspect that prices haven't been constant. So you've seen this because I've bumped it a few times. What I want to do is consider a specific example. So let's consider gasoline prices in 1981 and in 2005. So we have the nominal price of gasoline didn't, maybe went up by what, 1.5 times, roughly, a little bit more than that. Or excuse me, I'm sorry, that's wrong. Went up by a little bit more than 50%, as we will see in what comes next. And we might be tempted to say, oh my gosh, gasoline was so expensive in August of 2005, as opposed to what it was in 1981. And again, that would be potentially making a mistake, because at the same time that gasoline prices were rising, we also observed that overall, according in this case to the CPI, prices were rising. So what we really should be doing is constructing a real gas price. So my overall question here is gasoline more expensive in 1981 or in 2005? And we can get at this question in a variety of ways. So I'm going to do this first in the context of the table and then show you a couple of other approaches, just because I want you to understand that find the way that makes the most sense to you, and do it that way, and you will be just fine, particularly when it comes to quizzes and stuff. So if we wanted to figure out the real price of gasoline, then what we would be doing is, as we said, the real price of anything is going to be the nominal price. So let's say, or the real anything is going to be the nominal price of gas divided by, in this case, the consumer price index itself divided by 100. So the real price of gasoline in 1981 would be $1.42 divided by 0.885. And what we would observe is that if I did my calculations correct, this would be $1.60 a gallon. So the real price of gasoline in 1981 was $1.60 per gallon. And if we wanted to do this again, this similar sort of calculation, we could find the real price of gasoline in 2005. It would be $2.50 per gallon divided by 1.964, and that would give us a measure of $1.27 per gallon. And so what do we conclude from that? Of course, we would conclude that after correcting for inflation, gasoline was more expensive in 1981 compared, specifically March of 1981, compared to August of 2005. So this is one way of getting at this conclusion, is to construct the real price of gasoline. So again, a real anything is going to be the nominal value of that thing, so divided by the measure of the average price level. But as I said, there are other ways that we could get to exactly the same answer. And so one thing we could do is just look at the inflation rates. So another approach would be to look at the inflation rates. So the rate of inflation was the percentage change in the consumer price index. And so that would be 1.964 minus 0.885, divide that by 0.885, multiplied by 100 to express it as a percentage, and you come up with 121.92%. We could compare that to the growth rate of nominal or actual gas prices. So in 1981, the price was $2, oops, not 250, excuse me, $2.50 per gallon in 2005, minus $1.42 in 1981. Divide that by $1.42 in 1981, and again express it as a percentage. And we get that gasoline prices in nominal terms went up by a little bit over 76%. And so because overall prices rose more than gasoline prices, the real inflation adjusted value of gasoline declined from 1981 to 2005. And how do I think about that? Again, remember that we had this relationship that the percentage change in the nominal value of a variable is approximately equal to the percentage change in the real value plus the inflation rate. And so here we have, this is 76.06, the rate of inflation is 121.92, and so this would tell you the only way that what this relationship implies is that the percent change in the real value of gas is negative, of course. And if it's negative, that means that gas prices declined. So that's one way to do this. There's another way. You could have found either the 1991 price of 2005 gasoline, or you could have found the 2005 price of 1981 gasoline. So in the textbook, the authors, kind of give you these formulas. So here would be another approach. So approach number 3, you could have find one or the other, and it's going to tell you exactly the same story, comfortingly. The 1981 price of 2005 gasoline. What is that? Well, the way in which we would get that is we would take the price of gasoline in nominal terms. So this is the price of gas in nominal terms in 2005. And then we adjust it for the consumer price index relative values. So we would, in this particular case, take the CPI, which is going to be the measure in our example of the average price level or price index. We would take the CPI in 1981 and we would divide that by the CPI in 05. So in the textbook, the authors have a somewhat more general, rather than saying CPI, they just use price index, and that's true. It would be whatever measure of the average price level that we were using for our problem would be what we would stick in here. So we would have, in other words, $2.50 per gallon times the ratio of the two CPIs. And so that would be what we would have. And here you don't have to divide by 100, but because it's redundant, but I will do it just to be consistent. So this would be 1.964. And if you get that calculation, that comes out to be $1.13 per gallon, which is less than the actual price of $1.42 per gallon. So this would be actual, again, 1981 price. And equivalently, just flipping this on its head, oops, you could, we're going to keep them. I'm going to go here. Sorry about this. You could instead, oops, now we're red, find the 2005 price of 1981 gasoline. And so it's similar calculation, just kind of flipping some of the numbers. So this would be the price of, let's see if I'll be consistent. I think I did it this way. The price of gas in 1981, the nominal price of gas, and now you would be using the Consumer Price Index in 2005 divided by the Consumer Price Index in 1981. And so this would be what, $1.42 per gallon times 1.964 divided by 0.885, and that would give us a predicted price of 1981 gasoline in 2005 dollars of $3.15 per gallon. So that's bigger than the actual price of $2.50 per gallon. So we just have another way of saying gas prices, in fact, in inflation-adjusted terms, were more expensive were higher in 1981 compared to 2005. Now, this approach, in particular, is just like our indexation thing. So this is like what we talked about a few moments ago when we were talking about indexation. So essentially what we're asking is, if 1981 gas prices rose at the rate of inflation, so I should have said this is really like sort of method 4 of getting the same answer. If it is the case that 1981 gas prices rose at the rate of inflation, what would they have been in 2005? Well, we already know that it's going to be $3.15 per gallon, but let's just double check. We know that the rate of inflation, so the percentage change in P we calculated from before was 121.92%. So the indexed, if you will, gas price would be, again, the price of gas in 1981 times 1 plus the inflation rate. And so that would be the $1.42 per gallon times 1 plus 1.2192. And if you multiply that out, you should get $3.15 per gallon. So these are all just different ways of doing the same calculation. So again, we're saying that because we observed that the price of gas, in fact, in 2005 was less than $3.15 per gallon, that means that gas prices on average rose less than what the rate of inflation was. And so gas was more expensive in real terms in 1981 compared to 2005. Now, I'm the first to acknowledge, even though I find all of this to be quite interesting, that it's sometimes hard to wrap our heads around thinking about gas prices as our barometer and our example. But let me try to suggest that I did that because I actually thought about it as being not infused with a whole lot of emotion. But these kinds of problems are really important, and these kinds of calculations are really important. And an example of this would be the ongoing debates about what the minimum wage should be. So there's a lot of emotion about what a fair minimum wage should be and the assertions that the minimum wage should be higher. So where does that come from? I mean, it's one thing to just say, I want it to be, but you might want to be able to justify your argument. And so one of the things that you could do is to consider the information that I have on this particular slide. So on this slide, I have the value of the Consumer Price Index in December of 1980 and December of 2018 and 2019. In 1980, back around the time that I was kind of doing what many of you are doing, I was was in fact paid $3.10 per hour in my lovely ice cream shop job, and so when I look at 725, the old economy Steve part of me says, well, what are you complaining about, right? But of course, I know what people are complaining about, and it's correct. So, one thing that we can do is compare the minimum wage in 1980 with the minimum wage in 2018 and 2019, respectively. So, how would we think about this? Well, we could calculate the 1980. This would be one way to do it. 1980 real wage as, again, the nominal wage. We'll use a W for the nominal wage divided by the average price level. And again, in this case, we'll divide that in turn by 100. So this would be $3.10 per hour divided by 0.863, and that gives me $3.59 per hour. So this CPI means that the real wage in 1980 was $3.59 per hour. If we look at the real wage in 2018, it would be the nominal minimum wage. This is the federal minimum wage, is $7.25 per hour. and we would divide that by 2.51233, and that would give us an inflation-adjusted value of the minimum wage to compare to the 1980 value of $2.89 per hour. So this is one way of showing when people say the minimum wage hasn't kept up with inflation, how we get at that sense. So what I'm going to leave it to you to do for a participation question right now is to think about or I would ask you to calculate what is the real wage, what is the real value of the minimum wage in 2019. Okay, so we'll take a minute or two while you do that. So what I also wanted you to appreciate is that this is the consumer price index for a typical urban family of four, kind of the general thing that we talked about. If you were really, really interested, you could follow this hyperlink. It takes you to the Bureau of Labor Statistics CPI data tables, or a link then to the data tables, and you can see them just hundreds of different ways in which price indices are measured. So I just pulled the CPI for San Francisco, Oakland, and Hayward, California metropolitan area. You can see that should come as no surprise that prices, that the price index for overall prices in that area is higher than it is for the national average. And just for giggles, what you could do is look again for extra practice at the minimum wage, the real value of the minimum wage in San Francisco, Oakland, Hayward in 2018 and 2019, and just see how much lower it is even than what we found in our earlier discussion. What we can also do is think about, what this sort of other question, related question of maybe from a value judgment, what should the minimum wage have been? Or suppose the minimum wage had kept up with inflation, what should it have been? So suppose the 1980 minimum wage had kept up with inflation, what should it have been, say in 2018 or 2019? So I'll leave the 2019 to you to do. But for example, what you can do is think about this again as sort of along the lines of what we were just describing. So what is the 2018 value of the 1980 federal minimum wage? That's what I mean by should it have been. I don't mean that in anything other than, so it's confusing because I'm using sort of a normative word in a positive sense, but that's why I then wrote this. What is the 2018 value of the 1980 minimum wage? Well, again, what we would be doing is taking the minimum wage in 1980, so $3.10 per hour, and we would use the ratio of the two average price levels. So we would use the CPI in 2018 divided by 100 if you want, and the CPI in 1980. So this would be, again, $3.10 per hour times 2.51233 divided by 0.863. And what do we come up with? We come up with $9.02 per hour. So that's only to keep up with inflation. So what that is saying is if all we wanted to do was to ensure that people who were earning the minimum wage, the federal minimum wage, were able to maintain on average their purchasing power, then they would need to have been paid in 2018 $9.02 per hour rather than the $7.25 per hour that they were. So it's just another way of saying the federal minimum wage hasn't kept up with inflation. So then where do these calls for $10 an hour, $12 an hour, $15 an hour, where are these movements coming from? Well, some of it is tied into data that if you're interested in, I would be happy to discuss with you. But at its core, the saying that we want the minimum wage to only keep up with purchasing with the inflation means that there's no increase in workers' purchasing power. And to many people, that seems to be unfair because most workers are becoming more productive over time. So the $9.02 per hour, using the numbers that we have, would ensure that purchasing power has been maintained, but wouldn't account for any increases in productivity. And so this is why, again, we tend to see the calls for federal minimum wages being raised to the order of $12 or $15 per hour. So I hope that you found that interesting and compelling. What I'm going to do, well, let's see. Yeah, I guess we'll keep going here. What I want to do now is shift gears, and I'm shifting gears here because we're going to come back to interest rates when we talk about the cost of inflation in the next set of inflation notes. And it's just a whole lot to introduce all at once. And so what I want to do is introduce this now, have you think about it, and then we'll, as I said, come back to it and use it a little bit later. So, I think thinking about interest rates is always tricky. So, what I want to do is try to suggest that thinking about interest rates at a basic level isn't really any different than thinking about prices. So, just as you as a consumer might buy a loaf of bread for $3.50 per loaf at the grocery store, you might buy or correctly borrow $100 for a period of time for $5.50 per 100 uh, at the bank. And you can think about the bank as the money store. And similarly, if you were a bread seller, you're at the grocery store, you agree to sell a loaf of bread for $3.50 per loaf. If you're at the bank, you might agree to lend. So borrower is the demander side, like the buyer, and lender is the supplier side. So you might agree to lend, say, $100 for $5.50 per 100. So just as we express the price of a regular good or service as per unit, we express interest per unit. So conventionally, we express it as per $100, which is why then we express an interest rate as a percentage. So what is interest? Interest, the overall level, like $5.50 per year, for instance, is the price that you would pay if you were the borrower or earn if you're the lender. So again, the payment is by the borrower. The earning is by the lender for trades in financial capital. So one type of financial capital is money. And so we'll talk about money systematically in the next set of notes, but that's what we're going to be talking about here. So The key to understanding the economic function of interest rates is to recognize that if you have $100 today, it's worth more to you than getting $100 in the future. So before I launch into an explanation that I'm going to write as to why this is, why don't you think for a minute about why that is? So $100 today means that you derive the benefit of the $100 today. And you get that, right? So I'm not saying what you're doing with the $100. I don't even care. So for one person, using the $100 and deriving the benefits from it might be buying a really fancy coat, for instance, or a wonderful dinner with somebody. But you could just as well be, so pardon the reference if you're if you're not familiar with Disney, but you could be, Scrooge McDuck just standing around feeling $1 bills or gold coins that were worth 100. So it doesn't matter what the benefit is, it's just that you have the benefit from that. If you, let's take it from the perspective of the lender first. So if you have that $100 and you lend it, the $100. You don't have it today, of course. And so you lose the benefit of that, and you should be paid for giving up that opportunity. And so you should be paid for not getting those benefits today, whatever it is. And what are you being paid? You're being paid, of course, interest. Similarly, suppose that you're the borrower. Suppose that you really want to do something that costs, say, $100. You really want to go have that fancy dinner. You really want to buy that nice jacket, and you don't have $100. Well, if you don't have it, then you as the borrower should be willing to pay someone to get the $100 today and consume today. So how much would you be willing to pay? Well, again, you're willing to pay. It's going to be reflective of the benefits that you're going to derive from using that $100 today in whatever means it is. So then that also tells you that the higher our interest rates, other things equal, the greater is the priority on consuming today for both the borrower and the lender, right? So if I really, really, really enjoy that $100 today, right? Whether, I really, really, really want it, then you're going to have to convince me with a fairly high interest rate to give up my $100. Similarly, if you're the borrower and you really, 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 really want to buy something today and you don't have the funds for it, so you're borrowing and you urgently want this thing, then you should be willing to pay a higher interest rate. So we can think about higher interest rates as other things equal, so we'll talk about other things as the semester, as these notes and the semester goes on. But other things equal, higher interest rates should be reflective of a greater priority on consuming today rather than waiting and consuming at some other point into the future. And that's an important thing to recognize when we're thinking about interest rates. So, what I want to do is think a little bit more about this, and specifically how we think about the determination of interest rates. So, what goes into the determination of interest rates? Well, there are three things that we can think of it at their core as being important. So, one thing that goes into the determination of the interest rate is this notion of your preference for today's consumption. And this manifests as is um, part of the overall market interest rate is going to be in real terms, so in inflation adjusted terms, the risk-free rate. So just what is the pure urgency with which you want today's consumption in inflation adjusted terms. That's hard to sort of get a beat on, and we want to have some sort of bearing in reality from time to time. So what conventionally do we use for the risk-free rate and then the inflation adjusted risk-free rate? This would be the US, um, this is going to be a 3 month. It's known as a T-bill. T stands for Treasury, so a 3 month Treasury bill interest rate adjusted for inflation. So if somebody said, what's the risk-free interest rate? In nominal terms, you'd look at T-bills and you'd look at the 3 month one. And then for real terms, you would adjust for inflation in the manner that we're going to be describing. Now, why is that? So first of all, what is a treasury bill? When the government runs a budget deficit, it has to borrow, and it borrows by issuing little pieces of paper that say, I, the US government, promise to pay you a certain amount at some point in the future. And so that piece of paper has varying terms to maturity, and the term to maturity is the duration until you would be paid if you're holding that treasury bill. So a 3 month, that treasury security. So if you had a 3 month treasury bill, it would mean that you buy the little piece of paper, the IOU from the federal government, you hold it, say, for 3 months, and in 3 months, then you get the money you gave to the government back with some interest. And so Treasury securities have various, as I said, terms to maturity. So there are Treasury bills. Their term to maturity is under a year or under. There are Treasury notes, and these are securities whose term to maturity is under 10 years. And there are Treasury bonds, and Treasury bonds have terms to maturity on the order of 20 or 30 years. So, like a savings bond, if your grandparents bought you savings bonds, maybe when you were a little kid as a gift that you didn't appreciate then, perhaps that would be an example of a Treasury bond. So why do we consider these to be the risk-free rate? Well, risk-free means that we're really, really sure you're going to get paid back. There is basically no uncertainty. And the United States government, while it doesn't have absolutely zero default risk, is generally viewed as being as close to that as you can get. And there are, by virtue of lots and lots of years of deficits, there are lots and lots of treasury securities floating around. So the market for them is very, very deep. So there's no problem with buying and selling these things too, which also conveys a sense of calm to them by market participants. And you'll learn more about that in a finance class, and we'll have a little bit more to say about that later on in the semester. So, what's another component of the determination of interest rates? Well, there is the risk-free rate, but none of us gets to borrow or lend at the risk-free rate. Certainly, as a borrower, I'm not doing that. I am more risky than the US federal government, and so are you. And there's a variety of different risks that we might think of. And so, again, in a finance class, you'll take this up in greater detail. But the risk premium is the second component of the determination of interest rates, and it reflects the fact that borrowers should be willing to pay, and lenders have to receive an extra amount to compensate for all of the risks associated with lending. So there's a default risk, the chance that, I as a borrower won't pay you back. The longer is the duration over which a borrowing and lending arrangement occurs, the generally speaking, the more risky it is, other things equal. And certainly if we're dealing with transactions that cross countries where you have a risk that currency values can change, that's another element of risk in a borrowing and lending relationship. And then the third component is our good friend inflation, and specifically expected inflation. All right, so the goal would be that as a lender, if I'm going to give you my $100, I want to be able to buy next year at least the same set of goods and services as I could buy if I had that $100 right now. So, what does that mean? Again, that means that in real terms, I want my ability to purchase goods and services to be unchanged. So, incorporated into the determination of interest rates has to be some expectation of inflation. So if it is the case that we expect that prices are going to rise, that means that giving me $100 next year will have less purchasing power than if I had $100 right now. And so I need you to reward me for deferring my consumption. So in terms of thinking about this, we can do so with some notation. So first of all, in words, we said that if we were going to think about the underlying determinants of the nominal interest rate, it would include the real risk-free rate, a risk premium, and the expected rate of inflation. What we're going to do for the whole rest of this course is just to presume that everything that we're talking about doesn't have any other associated risk. So we've got no default risk, no currency fluctuations to worry about, all that kind of stuff. Of course, that's a gross misrepresentation of reality, but it cuts down on some of our notation and it doesn't sacrifice the basic points that we need to raise right now. So then if we were going to take this equation up here, this representation up here, we could say, aha, in notation, the nominal interest rate is going to be determined as the sum of the real risk-free rate plus the expected rate of inflation. And we'll go through an example of why it is a sum in the next set of notes. But what I want to do at this point is to again think about sort of the sequencing of things. So here is our equation, and notationally, the I is the nominal interest rate. The pi with a superscript e, so the superscript e here just means expectations. It's not logs or anything else goofy going on. And then r is going to be our notation for the real risk-free rate. So what we're doing is we're saying, before the fact, so borrowers and lenders are looking at the world around them. They can observe or get a good estimate of the real risk-free rate. They form an expectation of what inflation is going to be over the duration of the loan, say over the next year. And they add those two things together, and that gives a value for the nominal interest rate. And so it might involve some negotiation back and forth, but the borrower and lender then would agree to uh, this transaction at the nominal interest rate. So, for instance, I might say, well, you know what? I'm going to save that as a participation question. So here we go. And so now the lending has occurred. So let's consider an example. Let's suppose that we're going to consider a transaction for 1 year, that the risk-free rate is 4%, and people expect that inflation is going to be 1% over the year. And so the borrowers and lenders both agree that the nominal interest rate on this loan would be 5%. So for instance, if it's $100 that is being transacted, then in 1 year, the borrower pays the lender $105. So pays back the principal and 5% of that $100, so $105. So that's what we would be thinking about. So the borrower and lender agree to this 5%. That is the 4% risk-free rate and the expectation that inflation is going to be 1%. But this is, again, an expectation. So time passes, doop, 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 here's time passing, and there's an actual or realized rate of inflation that occurs. So the thing that distinguishes these is that, again, the little e here is to denote that we're talking about an expectation. When inflation happens, we can talk about what real interest rate was actually realized. And so this is what is the real, so the real return that the lender actually gets, and it is also the real payment that the borrower actually pays, right? So remember, they both agreed that 4% seemed like a pretty reasonable real payment to be making, but that 4% is either received by the lender or paid by the borrower if their inflation expectations were correct. So after inflation is realized, then there is the realization of the real return. So we have our final participation question here, and this will be the motivation for what will happen in the final set of notes for this week. So here, as our last slide, I have a depiction of nominal interest rates and then the estimated real return. And by estimated real return, what I mean, this is I couldn't edit the picture. This is the realized real interest rate, and it is, of course, the nominal interest rate. So nominal rate up here is I. This is I minus the actual rate of inflation. So notice a couple of things. So we can see in this period, say in the 1970s, the first part of the 1970s, inflation was on an upward trend. And you can, well, excuse me, nominal interest rates were on an upward trend, but during that time period, real interest rates start to drop, and for a period, they're actually negative. So what's going on there? That's going to be a reflection of the widening of that's going to be a reflection of increasing inflation. So the vertical distance between the blue and the red lines is going to tell us the measure of actual inflation. And what you can see is that nominal interest rates were rising, but particularly in this period, nominal interest rates were not rising fast enough to keep up with the pace of inflation. So the growth rate of inflation was faster than the growth rate of nominal interest rates, and real returns became negative. When you see, in this later period, say from about here onward, is yet another illustration of this idea of the great moderation. We see the gap between the two lines being a little bit until, at least the Great Recession and forward, the gap between the two lines being more consistent. So we have more stable rates of inflation, and we also see a fairly steady decline in nominal interest rates overall. You can see the abrupt drop in nominal interest rates as a result of the Great Recession and more or less continuing to the present. And then we have a couple of interesting instances in which the real interest rate was above the nominal interest rate, and that's going to be a reflection, as I have right here, of the consumer price index being negative, right? So if it is the case that the real interest rate is the nominal interest rate minus the rate of inflation, whatever the nominal interest rate is, excuse me, minus a minus number, right, is going to mean that we have a plus. So if this is, for instance, if this was basically 0 and the rate of inflation was -1, then that would mean that the real interest rate would be 1%. It wasn't that big, of course, but that would be an example of what's going on. So we're going to take this relationship between real and nominal interest rates, expected and realized inflation, and use that as part of our discussion of why we actually care about the problem of inflation in a macroeconomy. And that'll be in the final set of notes coming up. Thanks as always for listening to my rambles, and we'll check in for one more set of notes this week.